Okay, so uh, one thing I just want to say is if you are offended, also it's okay. But the point is, if you are unable to talk, if you are unable to discuss with the faculty, then it's I think I will continuously saying the topic. Suddenly in the middle you will break the topic and you will ask what did you say it from the first. I don't want to say it again and again. So I want you to be very clear on what we are discussing. And one more thing is that everyone should be very I can say they have to talk to the faculty. If they are unable to talk to the faculty, but to continue the sessions. So please respond to the questions whatever has been discussed. Then we to the concepts. So if you are unable to talk to me, something difficult for you. Any which ways, from the last two sessions we have discussed about the last two demos. We just discussed about the concepts related to Docker, what is meant by Docker, and how Docker came shared, and what is meant by Docker, or I mean, what is meant by a container, and how we can run the applications inside the container. These are all things that we have seen in the last two sessions. So before I go into the session, let me explain you this Docker and Kubernetes, whatever you are about to get, you are about to learn. These sessions will be uh, the total duration will be 20 to 25 days. I'll make it as 25 days, and then totals. Here you are going to get a very clarity about the Docker and Kubernetes, and the session will be 8:30 a.m. to 8:30 a.m. to mostly 9:30, or in some cases it might be extended up to somewhere like 10 o'clock also. And then syllabus for this entire course is syllabus of this course. In Docker, what you are going to learn. In Docker, you will be learning about the Docker and container basics. Container basics. Here you need to understand one thing. Docker is just an application. So here we are going to understand about the containers. So how a container will be created inside the Docker, how we can generate the image for creating the container, what is meant by volumes, what is meant by bind mocks, what is meant by Docker compose. Like that, we are going to mostly concentrate on the containers. So try to understand that. Docker networking, and then we will be discussing about Docker images, and then Docker volumes, Docker compose, Docker swarm. So these topics we will cover in the Docker. Okay, and when you come to the Kubernetes, we are about to introduce a new topic in the Kubernetes, but we'll see whether it will be implemented or not. So the first one is microservices. Microservices. It says monolithic architecture. Then we are going to discuss about Kubernetes creating cluster creation with Kubedium and KOps. So these are the things that we are going to see. And the next one will be we will be discussing about Kubernetes workload components. So there are so many workload components out there: pods, replica sets, daemon sets, deployment stateful sets, like that. We are going to discuss about those things. And then Kubernetes services, and we are going to discuss about ingress controller. Yes. Then we will be discussing about Kubernetes secrets and config maps. Before secrets and config maps, we will be discussing about the probes and the sidecar containers. And then we will be discussing about Kubernetes namespaces, Kubernetes namespaces, and the resource quota. And then we have to discuss about RBAC, Then we'll be discussing about the concepts related to advanced scheduling. Advanced scheduling. The next one will be Kubernetes storage, and we'll be discussing about Kubernetes secrets and config maps. Then we'll be discussing about Kubernetes network policies. Then we have to discuss about customize. Okay, it is customize only K. It will start with K. And the next one is we'll be discussing about help STO service mesh. STO mesh. And we have to discuss about set GitOps. Okay, these are all we are going to work, and then we will be covering monitoring and logging in Kubernetes cluster. These are the topics that we are going to cover in the entire Kubernetes. Okay. So to cover all these topics, for Kubernetes itself, it is going to take some 17 to 20 days, and for Docker, it will take some 1 week. So that's why I have made it as 25 days of Docker and Kubernetes sessions. Okay. So in the last session, we discussed about the Docker. So basics of Docker, what is meant by Docker, what is meant by container, and how a container will be running inside the Docker, what is the how we can run the applications inside the container. These are all the concepts that we have seen in the last session. In this session, what we are going to do is we are going to work with the concepts related to, we need to understand the Docker architecture. Okay, Docker architecture. Okay, what is this Docker architecture and how we are going to work with this Docker architecture? This we will discuss about the concepts. So first of all, let me do one thing. I'll deploy a Docker server. I'll deploy a Docker server in the AWS account. So go with Firefox. Okay. Let me log on to my AWS account. Create an EC2 instance over here that is just like a server, and let us see what we can do with the Docker components. Launch instance Docker-server, and I will go with the Ubuntu operating system. Just for your understanding, I am saying it, guys. Tomorrow we will see the entire. So this is the last demo for the Docker. Okay. T2 micro, and key pair will be the default key pair, and I want to create it here. Okay, good. And launch the instance. So once we have launched this instance, we need to install the Docker on that server. So how we can install Docker on the server? Let's see that. But before I do, go to the security groups. Sir, I don't know about AWS. No problem. We'll discuss about the concept of how we can install the EC2 instance in our environment. We will get a clear picture about that. Okay. So now we have the EC2 instance configured over here. Now let me access that EC2 instance and install the Docker inside this EC2 instance. Okay, so here we have our EC2 instance available. Good. So we need to install the Docker curl -sl https://get.docker.com dash. So when I give this command, Docker will be installed automatically. So after installing the Docker, let us understand the Docker architecture, how the containers will be created, how Docker will communicate with the users. So to understand that, let us see here. So in Docker, you will have three major components. But basically, let us understand about the two components and then we will discuss about the third component. The first one is Docker client, or else I will call it as Docker CLI. So whenever the user wants to communicate with the Docker application, he has to give certain commands. So these commands will be given through the Docker CLI with the Docker command line. So we are going to give this Docker anything, Docker PS, Docker run, Docker build, and Docker create or else Docker network. So like that, whenever we are providing any command in the beginning, we are going to say Docker. So a keyword will be given called as Docker. So when we give this keyword called as Docker, then the Linux machine will understand, okay, the user is trying to communicate with the Docker application. So that is what Docker CLI is all about. So once the Docker is installed, here we got the Docker installed. So see here, Docker info. Okay, so it is giving me the information about the Docker which got installed on my server, and Docker PS. Whatever the containers that are running on my server can be displayed with the help of the command called as Docker PS. Docker PS-A. It is going to display all the containers that are created and that are created, stopped, and running containers. So -A means all. So it is going to show every status. So here you can see when my container is in the running state, so then you can use the Docker PS command. So if you use the Docker PS command, it is going to display or else it is going to print the commands that are, print the containers that are in running state. So when you give the command Docker PS-A, then it is going to print the containers on the terminal which are in running state as well as it is in shutdown state or it is in created state. Any state, the containers are going to be displayed with the help of a command called as Docker PS. So if you see here, in the beginning, I am giving Docker only. Okay, so for example, if I want to check Docker images, Docker network ls, okay, Docker volume ls. So to check anything or else to create anything, in the beginning, we are providing the command called as Docker. We are providing a keyword called as Docker. So that is what Docker CLI is all about. So when you give this command, so automatically it is going to trigger in the backend. There is a Docker daemon will be running. Okay, there is a Docker daemon running, and this command will hit the daemon. The Docker command will hit the daemon. Docker daemon will be there. Okay. So now what is going to happen? For example, if I want to create any container, so I am giving Docker run command. So Docker run command is helpful for creating the container. Now it is going to hit the Docker daemon. So inside the Docker server, you will be having a component called as local registry. Local registry, where the images which are helpful for creating the containers are stored. Images are stored to create the containers. Okay, so in local registry, the images will be stored. So now here, what is going to happen whenever I want to create the container? Now the Docker daemon will search for the image in the local registry. It is going to search for the image in the local registry. Local registry means in your Docker server, it is going to search about this. So if the images are available, then with the help of this particular local image, Docker daemon is going to create the container. If the images are not available, then what is going to happen? I will tell you. So there will be a container space. So where your containers are going to be created and applications will be running. So this application creation, I mean container creation can be done with the help of the Docker images. So now if the images are not available, if the images are not available, then what Docker daemon is going to do for us? There is a third component called as global registry. Whatever the registry that you are seeing here, this is called as local registry, which is created inside the Docker server. But there is a global registry. So the default global registry for Docker is global registry. The default global registry for Docker is Docker Hub. Docker Hub, you will have unlimited number of images will be there. So among those images, one image will be pulled out. So now what is going to happen? So in the Docker Hub, what will be there? There will be globally accessible images are available. So now whenever you want to create the container, if the image is not available inside the container, then Docker will go and check in the global registry. Okay, here it is going to check. So by default, Docker knows the Docker Hub URL. So it will go to the Docker Hub and pull out the image from the Docker Hub and put it in the local registry. From the local registry, it is going to create an from the local registry, whatever the images are available. So with the help of that images, it is going to create a container. So this is how the containers will be created inside your Docker environment. Sir, if we are having the custom images, then so if you are having a custom images, the custom images cannot be found in the global registry. You will have your own applications. You are working for a bank. So that bank related application will not be available in the Docker registry. The bank related application image will not be available in the global registry. So what you have to do? So you have to write a Docker file and build the image. So when you are trying to build the image, Docker daemon will understand, okay, the user wants to build the image, and after building the image will be stored in the local registry. So this is how the entire functionality will work. So this is called as your Docker architecture. Now, if you can see here, Docker architecture, the same diagram will be there. I hope you are able to see this. Look at that. When the client is trying to access anything, the response will go to the Docker daemon, and if the images are available in the local registry, it is going to create the containers. If the images are not available, then it will go to the global registry, pull out the images and store the images over here, and then it is going to create the container. If you want to build any image, you can build the image with the help of Docker itself. So this is how the Docker architecture will be looking like. Do you understand the question concept here? Any questions? Do you understand the concept? Any questions?
No, sir.
Good. Aman?
No, I'm good.
Okay. Kishore?
Good.
Mohan? Mohan? Okay, right. So I hope everyone is okay with this architecture. So now let us see what is going to happen. So you said that it is going to happen in this fashion. What is the proof? So now I want to create a container. I want to create a container. So Docker PS, we don't have any containers. Docker PS -a, there is no container running. Docker images, we don't have any images available in the local registry also. So here you can see in the local registry, we don't have any containers. Now what I will do here is Docker run -itd hyphen name new container with the image nginx. I want to create a container. So if I want to create a container, this is the image which I am using. This image is not available in my local registry. So now what is going to happen? So when I hit enter, see that unable to find the image nginx latest locally. Then what, from where it is going to pull out the image? It will go to the hub.docker.com. Okay. from here it is going to pull out the image. Nginx. Here you can see this is the official Nginx image that is available. So here you can see Nginx latest tag will be there will be several versions will be there. Among those, it is going to pull out the latest tagged version. So this version is pulled. Okay. So now if you can see here, Docker images. Now the image is available inside my local registry. So now what has happened here as per the diagram, if you can see, whenever I am trying to create a container, so it will hit the Docker daemon. So Docker daemon is finding the image inside the local registry. As it is unable to find the image in the local registry, it is pulling the image from the Docker hub. From here, it is going to pull the image, and after pulling the image will be stored in the local registry, and then a container will be created with that image. So this is what going to happen in this concept. So now let's see whether we have our Docker PS container running. Yes, here you can see a container is created with the name new container, and this is the container ID. And the image is stored inside the local registry. Here you can see Nginx image is stored. So this time, from the next time onwards, whenever I want to create the container with the same image, docker run -itd -name new container 2 and with the image Nginx. So this time it is not going to check in the global registry. Why? Because the image is available in the local registry. So it is going to create the container. So if you can see here, new container 2 is created. So it is not going to pull the image. Already it is available in the local registry. It doesn't need to pull the image.
Chaitanya, one question here. Is there any possibility, whenever we are pulling the from the global registry, without copy into the local registry, directly create the container?
It has to pull the image into the local registry, then only the container.
Yeah, I got that point. Without storing into local
That
repository
is
is
what
not
I am saying. No, it's
okay.
not possible. Yeah, that is what the architecture is also saying. No?
Yeah, why? Because like for example, my space have the less space. If I want to store the total images into my local, sometimes.
You have to make it less than. No other
Okay.
way. Definitely, it will be stored in the local registry. Directly, it is not going to point the global registry. Okay.
Okay.
See, for example, you have pointing towards the global registry. Okay. Just understand, if you want to make any changes in the image, you will pull the image, you will store in the local registry. On the top of that, if you want to make the changes, you can make the changes. But if you are referring to the global registry, if you make the changes in your image, then what will happen in the global registry also, the image completely will be changed. No? That
Okay.
image can be accessed by the other persons. No? When that image is accessed by the other persons, whatever the new components that you have added will be accessible by the other persons. No? What is the
Okay.
necessity of accessing that components for the other persons? Are you getting the point here?
Yeah, I got that point. Okay, but in the Docker concept, but this is not possible, right?
That is what I'm saying. It's not. You have to get the
Okay.
image, then only you can be able to create the contents.
Okay.
Any other questions?
I have a quick question. So, like, for example, now we were pulling the latest image. Let's say whatever we pulled today, and tomorrow they do an update. The tag changes, the latest tag now is a separate image with some new changes. So, our application will be running off of the today's latest changes, or
No.
how? Because
You
once we
purchase,
put,
1 second, let me come. So you purchased a Windows 10 laptop. Okay. You bought it to your home and you are not connected to the internet. Now, if there is Windows 11 upgrade is there. Okay, if it is a genuine version, then if you connect to the internet, it will ask you to upgrade. So it is your wish to upgrade it or not. So that is what your question is all about, right? So if there is an image, if I pull the image and tomorrow if there are some updates that happen, then automatically the whatever the image that I have pulled from the Docker hub will be updated or not. It won't happen like that. So just like your computer, you brought a computer with Windows 10 operating system and you are running in your in your home. Okay, you got an update. Until you update the computer, it won't happen. You have to manually update it. In the same manner, you are creating a container with see, one thing that you need to understand here is whenever I gave the command nginx, so here the image name is nginx. Here I can put any version also. So like you can put any tag, but if I don't specify a tag over here, then automatically Docker will attach a tag called as latest. Here it doesn't mean that I want to pull the latest image. So if I can show you here, Docker images, it pulled the latest image. Why? Because I did not mention any tag in the, whenever I am creating the container. If I mention a tag, Docker run hyphen itd hyphen name, uh, test container and nginx, let me go with a tag over here. For example, I'll go with whatever the vulnerability list tags are there. Any tag like 1.2.9.perl. So I want to download this. I want to download this image. So if I don't mention a tag, automatically it is going to attach a tag. Docker is going to attach a tag called as latest. That's it. So if you see here, it is going to download that particular image. Okay. So the point what you need to understand here is latest in the sense the image is not a latest one. So whatever the tag, if you don't specify the tag, Docker will attach a tag called as latest. And inside that, if there is any upgradations are happened, then again you need to re-download that particular image. That should be happened. So if you're getting the space constraints, then we are having another concept in the Docker images that is called as layers. Any which ways we are going to discuss about that. Okay. So the point what you need to understand here is latest is just when you don't provide the tag, Docker is going to attach the tag called as latest. That is the first point. And the second point is that when you are asking if there are any updates happened in the image, in the global image, whether those updates will be occurred in my container or else in my image. No, it won't happen like that. It's just you brought a computer to your home and you, if you are connected to the internet also, you need to manually update the computer. In the same manner, here you have to manually pull the image to your local registry. Until then, whatever the old image is there, with the help of that old images only, you can run the containers. Got the point
So,
here?
so if the latest is updated, if I keep running the Docker run again and again, it will keep using the image from the local registry. So what would I need to do? Do a separate Docker pull? Do you mean a command to pull the
Of
latest from
course,
the?
of course. If you want the latest, you have to pull it.
Okay.
Okay.
Yeah, in addition to the same question, if I want to be pull that one, I will get the new image, right? So if I want to be update the same container,
Yeah, you have to update the container.
only update, right? It's not a creating
No,
the new
no,
one.
oh, no, no, it's not like that. See, the containers will not be updated in that fashion. You have to understand the point here is the containers will be running with the old image. So whatever the container, so if you can see Docker PS, so the container is running with the image Nginx latest. Both the containers are running with the Nginx latest only. When I pull the new image, so this container will not be updated. There is no option to update that. You have to kill this container and then you have to recreate the container. That's the only option.
Okay.
So you
Always,
asked me
always
that
creation. Always creation.
always you need to go for if there is any updated. For example, just forget about these things. Just forget about these things. Okay, containers and all the things. Let me ask you a question. You have an application running. Okay, you have a Java application or else you have a Python application running. there is a bug in that application. So whatever the version 1 build that you have created, there is a bug in that application. Now what you are going to do, you will be updating the source code. After updating the source code, so you have to kill the previous version application and then you have to create the new version application. That is what you are going to do now. When the old version of application is running, are you able to update that application?
We will stop the server and redeploy the application.
Stop the server in the sense you are killing the application, no?
Yes, yes. Stopping means stopping the application and killing the application.
Killing the application in the sense you are removing the application on with the process, no? And then you are
Yes.
updating it. Here also the containers, what containers will do? Containers will run the application. So when they are running the application, what is going to happen if a new update is there? Then you have to kill the application. Why we are creating the containers? Containers will be running until the application is running. If the application is killed, then automatically the container will be killed. Automatically the container will be terminated or deleted. So then what you have to do? You need to reinitiate a new container for the latest updated application. Okay.
Yes, got it.
Okay. So that is about the concept of your Docker architecture. So then we will be discussing about the lot of concepts related to Docker in the upcoming sessions. So today is the last demo. And from Monday onwards, whatever the classes that you are about to attend, those sessions, those sessions will be having the premium link. Okay, so you have to enroll for that and you will get a link for your email and you have to join with that link. Okay, once you have joined the session, you won't regret that we are in a wrong place. I can assure you that. And whatever the topics that I have discussed right now in the syllabus, we are going to cover each and every topic on that. So this is about the course and course content and the basics of the Dockers. So from Monday onwards, we are going to work with the Docker networking, Docker container lifecycle, and then we will be working with the Docker images, Docker volumes, and then we are going to discuss about the rest of the concept. Now let us get a brief understanding about the Kubernetes. Right now you got an understanding about Docker, Docker architecture and containers. So now let us have a brief understanding about the Kubernetes. So here one thing that you need to understand is containers are stateless. Whatever the containers that we have created in the Docker application, these containers are stateless. Stateless means the containers will be running, application will be running inside the container. Suddenly, due to any reason, if the application is, the container is overloaded, the container will terminate. Who will manage that? So containers are just like a small kids. Okay, 2 to 3 years kids will be there, no? So they will be doing all the mischievous things. So they will be roaming all the home and they will throw all the objects. So whatever they want, they will do that. So the point what you need to understand, there should be a guard who is going to monitor those kids. In the same manner, there should be a manager or else there should be a pod to monitor these containers, and this is called as an orchestration tool, so which is nothing but your Kubernetes is especially designed to manage and monitor your containers. So when the containers are running, so suddenly if there is a problem with the container, so automatically Kubernetes will redeploy a new container. If there are number of containers are running, I want to do the scaling. Scaling means increase the number of containers depending on the rush, whatever the load is there. So depending on the load, I just want to increase the number of containers. So auto scaling can be done with the help of Kubernetes. Self healing can be done with the help of Kubernetes. Not only that, whatever the services that you want to expose and that you want to give to the end customers, that we can do with the help of services, and we can restrict the each and every container with the help of resource quotas. So this particular container should be running with this much amount of CPU and this much amount of RAM. We can do it with the resource quotas. And then when you go to the storage, persistent storage, how we can provide the storage, everything. So related to the containers, whatever we want to do, we can manage and monitor those containers with the help of Kubernetes. So that is what we call it as an orchestration tool. So orchestration tool in the sense which is going to manage certain objects. So Kubernetes is one of the orchestration tool. The examples are Kubernetes, OpenShift in Red Hat Linux is another type of orchestration tool. And when you go to the HashiCorp, we have Nomad. Nomad is one of the orchestration tool. And for Docker, it is Docker Swarm. Docker Swarm is into the development environment. Still, it is not into the production grade. But still, if anybody are using the Docker Swarm can also do the orchestration. So these are all the multiple orchestration tools that we are having in the containerization platform. Okay. So we have to discuss about this. Major number of companies are using K8s, including with certain AI tools. We are not going to discuss about the AI tools any which ways. We will be clear cutly following through the Kubernetes, and a new component has been unlocked, that is customized. So what is this customize and how we are going to work with the customers, we will see in the Kubernetes session. Okay, so that's it from my end. If you have any further things to ask related to the syllabus, related to the technicalities, anything, you can ask me now. So the questions are open for the last 5 minutes.
So you are creating Kubernetes by using AWS or Azure?
AWS.
Okay.
We are using the cloud AWS to configure the Kubernetes. Why? Because we have a tool called as KOps. KOps will support only AWS. It is not supporting Azure. So we don't have any KOps tool, like KOps tool will not support Azure. So they are still in the implementation stage, but it is in the beta version. The KOps is the beta version for Azure. So once it is updated, we can go to the Azure option. But right now we are working with the AWS.
Okay. And whenever we deploy that, so we are using the Argo CD in GitOps.
Yeah, that is what I have mentioned.
So we cover Argo CD as well, right, in GitOps?
Yeah. Yeah.
Okay, got it.
So are we going to install Kubernetes or are we going to use the managed Kubernetes from AWS?
Managed Kubernetes is not. I am not going to work with the managed Kubernetes. We are going to
Okay.
run the clusters. The AWS EKS is a very simple concept. It's not a very big concept. But creating the Kubernetes by yourself, and yes.
Because I am not a AWS background, that's why I asked, sir.
What is there? AWS or Azure? Both are the same only, no? In AWS, the components are called as VPC, subnets, EC2 instances. When you go to the Azure, they are called as VNets, subnets, and then virtual machines. In AWS, we don't have the resource group concept. In Azure, we have the resource group concept. In AWS, we don't have the subscription. In Azure, we have the subscriptions. Rest of the things are the same. In AWS, we are having S3. When you go to the Azure, that is called as blob storage. Both are same.
Okay, sir. Yeah, got it.
That's it.
Is there any advanced concept will be covered in this topic like tent and toleration like that or carpenter?
Taint and tolerations will come. Those are not advanced topics. Those are included in the advanced scheduling.
Okay. Okay.
Okay.
And carpenter?
Whatever the advanced topics are there, see, I have clearly mentioned what we are going to cover here. Don't ask me any after than that. Okay. We are going to cover these things.
Okay. Got it.
Okay, guys. Anything else?
No.
Right then. Have a nice day, and we'll meet in the next session.
Yeah.
Bye, guys.
Thank you. Have a nice day.
Yeah. And one more thing before I am closing this, I just want to tell you one thing. So this is the last demo. So those who are interested can join the session. And the thing is that So no person is lifting the call. So DurgaSoft is asking me why they are not lifting the call. So it's your response. At least respond for the calls, whether you are interested or not. Just say one thing. No, I'm interested. I did not interested. Even see, I know you might be very busy. So, but taking a call just for 10 seconds, it won't be very big deal. Or else at least type a message. So I'm interested. I will join. If I am not interested, I won't. It's not like you have to join. We are not going to call you again and again also. Okay. So if you are interested, just say that. But giving the wrong numbers, giving the wrong email addresses, that's completely a mistake. So if you give the same email address, we send in if you pay the fees, we send the email link or else we send the Zoom link to that email. Are you able to get it? Again, you have to call back to DurgaSoft and say that we did not get any email link. So if you give the that dummy email or else any fake email address, if I want to share some notes, then to which email address I have to share the notes? So we are not collecting your data here. First thing, we are in a perspective that if you provide a proper mobile number or email address in the beginning, we will understand. Okay, so this candidate is interested. This candidate is not interested. That's your wish, guys. Any which ways. Okay, if you again some of the candidates will after completing the session demos, they will ask me, sir, how I can contact the DurgaSoft. If you provide a proper email address or proper mobile number, they will only contact you. No. Anyways, so if you are interested, then you can enroll for the concepts. If you are not interested, also just say only one thing: I'm not interested. I'm not joining. It is just a matter of 2 seconds. Okay. Have a nice day, and we'll meet in the next session. Bye, guys.
Thank you all.
Thank you.